Okay, so chapter 10, section 2. Today we're looking at a quadratic equation and we're adding this middle part of the equation in, the plus bx. In the first section we simply had y equals ax squared plus c. We knew it was quadratic, as you just said, because the input was being squared, and that's what creates a quadratic equation. Now today we're going to add the middle part of this trinomial into the equation and see how that affects the graph. So a standard form quadratic equation is written ax squared plus bx plus c. Alphabetical order, descending in degree. Okay, so we've already learned with these that we get parabolas. When you see an x squared term, you're going to end up with a parabola. And how do you know when it opens up or when it opens down? What do you look at in this equation, Tom? A. So how do you know it opens up? The A is good. And if it opens down, of course, the A is negative. And then we also already know something about how to find the width, how wide the parabola is. So how can we make the parabola really narrow? What would we do with the A value? It would be A of what? What makes the parabola really narrow, closer to the y-axis? Jenna? Narrow. Greater than 1, right? A is greater than 1. Notice we're using absolute value, because even if it's a negative, like negative 10x squared, it's really stretched. It just happens to be also reflected. So we call these stretches, right? When your A value is greater than 1. And then in order to have a shrink or a wider parabola, the A value is, Oscar? And also greater than 0. Okay? And never 0, because that wipes out the quadratic equation. So today we're going to learn about finding the axis of symmetry. We haven't talked much about it because all of our graphs have had their vertex on where? Where has the vertex been every single time? On which axis? The y. It's gone up and down, but it's been on the y-axis. Today we're going to find out that the axis of symmetry, where you would fold the parabola onto its own self, can move and not be on the y-axis. So we're going to come back and finish this rule box after we go try a problem. Okay, so if you knew nothing more than you know now, and somebody gave you this graph, this equation, and said graph it, I mean, one thing you would know is, oh, there's a squared input, so this is a quadratic. So what shape would this be? This would be a U shape. Would this thing open up or down? How do you know? Positive out here. Good. So you would say, okay, this is going to be a U shape that's opening up, right? And that 2 does what to the parabola? A little bit of a stretch, not a major stretch, but a little bit of a stretch. And then we're not used to this middle term being here, but the plus 7 would do what?
Translation.
Translation up, right? Translation up. Okay, so what we don't know is necessarily where the axis of symmetry is. So if you knew nothing else, what would you do? You would graph it. Good. So that's what we're going to do. Let's just graph it. How would you know where to put the points? Make a table. Let's just make a table. So what values would you like to put in the table? Okay, so people are saying, you know, the values we've been using, negative 2, negative 1, 0, 1, and 2, we like those. So what do we get when we plug these in? If you knew nothing else, you could do this. So let's go ahead. Let's start with 0. It's such an easy number. 0 minus 0 plus 7 is 7. We're just plugging them in here. Let's plug in 1 1 squared is? 1 times 2 is 2 minus 8 times 1 is 8 plus 7. What is 2 minus 8 plus 7? Negative 6 plus 7 is 1. Okay. How about if we plug in 2? Let's see, 2 here, 2 squared is 4 times 2 is 8 minus what? 16? What is 8 minus 16? Negative 8 plus 7. Negative 1. Okay? Let's plug in negative 1 to see what happens. Okay, when we plug in negative 1, what is negative 1 squared? So we have 2 times 1. But when we plug in negative 1 here, we have negative 1 times negative 8, which is positive 8 plus 7. So what do we have now? 2 plus 8 plus 7? 17. Okay, so that's big. Okay. And you also said negative 2. So if you plug in negative 2 here, you get 4, right? 4 times 2 is 8. And then you plug in negative 2 here, and you get plus 16. That right there is 24. Plus 7 is 31. So this is kind of weird looking. Do we see symmetry in our table? No. Okay, so if you were to plot these points, I don't even have room given I'm using a scale of 1 here. So I have 0, 7, 1, 2, 3, 4, 5, 6, 7. I have 1, 1. I have 2, negative 1. And then I have negative 1's way up here, so, way up there. Negative 2 is way up there. So do I look like what is the shape supposed to be? The shape of this thing is supposed to be a U shape. And so does it look like a U is coming out of this?
No.
Well, it's kind of coming from way somewhere up here down, so wouldn't you expect it to be turning up somewhere to the right, right? So we may need to find some x values to the right. What would be bigger than 2? Let's plug in 3 then. Go back to our equation, plug in 3. 3 squared is?
9
times 2?
18.
18. 8 times 3? 24 plus 7. What is 18 minus 24? Negative 6. Good. Plus 7?
1.
Is 1. Ooh, that's interesting. 3, 1. Because I had a 1 when I plugged in 1. Do you see this? And now I have a y value of 1 when I plug in 3. So 3, 1. So now do I see symmetry? You see this? I need to curve this a little bit. It's a U-shaped curve. So now I could kind of just try to make it match up with the left points, right? So it's, going up. Okay. So what happened to the vertex or the axis of symmetry? It moved over to the right. And so we added this middle term, which says negative 8x, and it moved the whole graph to the right, this term, which is something new for today, right? So it's a negative 8x, and we moved to the positive right. Isn't that interesting? You would think maybe that if I had a negative, I would move which way? To the left, but no, we see we're moving to the right, okay? So there's a little formula that we want to learn because this point, this vertex is so unique and special. Remember, it lands on the imaginary axis that you could fold the parabola on, and you would have a point reflected on either side of it, right? So it is the most critical important point to find, and there's a little formula that we'll use to find it, and it is x. The x value of the axis of symmetry, the axis of symmetry is just a vertical line, so we can write it as x equals negative b over 2a. So let's try that with this equation. This equation has, for b, negative 8. So what is, let's just plug it straight in. Negative, we plug in b, which is negative 8, so the numerator really becomes 8, a positive 8, right? And then over 2 times a, which value up here is a? 2. And so 2 times 2 is 4. So when I reduce this, 8 divided by 4 is 2. Is our axis of symmetry over there on 2? X equals 2? See? X equals 2. That's the equation of a vertical line. X equals 2. Okay? So the reason we want to find this is because that is where we will find our really important vertex, right? And so we want to identify that early, right away, and then find points on either side of the vertex to graph. We don't want to waste our time with these points down here that we didn't need. We want to find the vertex and then go one place to the left of it, one place to the right, 2 places to the left, 2 places to the right, and we'll have better points to graph, right? Because we want to see where the U is. Okay, so let's go back to our rule box and make a note of this. How to find the axis of symmetry. There it is, the formula. And as we just used, we use the axis of symmetry to find the vertex by plugging the x value from the axis of symmetry into the equation, and you'll find the y value of the vertex. The vertex is the maximum point if the parabola opens down. It's the minimum point if the parabola opens up. Okay? And we're going to come back and fill this one in later. Where is the y-intercept in this graph we just created here? Do you see it in the table? When x is 0, y is 7. And where is it in the equation, people? C. C. So let's go ahead and finish the rule box. Your C is your y-intercept. So the first question is, can you find the axis of symmetry and the vertex? So go ahead, pause the video, come back and see if you found it. So the formula we need for the axis is, everyone, x equals
negative b over 2a.
2a. So when we plug in b this time, b is a positive. So we have negative 12 over 2 times a, which is negative 12 over 6, which is what? Negative 2. So your axis of symmetry is at negative 2. So your vertex is always on that. So we just need to find the y value of the vertex by plugging in negative 2 for x. Good, so negative 20 is our y value when we plug in negative 2. Does this thing open up or down, this parabola? It opens, look here, up. This is a positive value. So this is the lowest point, the minimum, because it opens up. Okay, so we'll graph this using what we've just learned about the axis of symmetry in the vertex. So first step is find your axis of symmetry. Part B is find your vertex. And then you're going to make a table with 2 points on either side of your vertex, right? So pause and come back and see what we got. Okay, so we start with our axis formula. We plug in carefully, and we found the axis at negative 2. So the vertex will be on the axis, so we plug negative 2 into the equation. Okay, so we plugged in negative 2, and we found that the y value of the vertex is at negative 13. So we could go plot that. We would go negative 2 and then negative 13 is somewhere down here. Negative 2, negative 13, that's our vertex. So when we make our table, we want the vertex right in the middle of the table. Negative 2, negative 13. And then it'd be nice to have a couple points on either side of it. So what is 1 greater than negative 2? Negative 2 plus 1 is negative 1. What is negative 2 minus 1?
Negative 3.
Negative 3. Now let's add 1 to negative 1. Negative 1 plus 1?
0.
0. So if we take away 1 more, we're at negative 4. So there, now we have symmetry in the table, so we should have symmetry in our math, right? So find those values. Okay, so the easy number to plug in was 0. We said that's going to be your y-intercept, so it is, isn't it? It's on the y-axis. Very good. So where else will we find negative 1 y value? Negative 4, because it's also 2 away. Plug it in and you'll find that it is true. You get that symmetry. So knowing about that y-intercept is cool because you can see that it's 2 away from the vertex, so it has a corresponding point 2 away on the other side. It's very useful for graphing. You could just graph with vertex and y-intercept and its opposite. Pause this and find the minimum. And there you go. And there you